Can artificial intelligence really replace engineers in doing calculations? Let's find out as we analyze a simply supported beam using three methods: the manual calculation, ETABS, structural engineering software, and an AI-powered Structura-GPT. Let's begin with the fundamentals, the manual calculations. You have here a simply supported beam with a span of 6 meters. And let's put the uniformly distributed load that's our UDL of 10 kilonewtons per meter. We will neglect the self-weight of the beam for now. This is just for an example. So what we're going to do is to calculate the bending moment, the shear force, and the reaction using the manual calculation. As we all know, especially those taking structural engineering course, a simply supported beam, the bending moment is the WL squared over A. Just the W is the uniformly distributed load, the L is the span divided by 8. So we have the W is 10 and the L is 6 squared divided by 8. So our bending moment is, let's use this, 10 times 6 times 6 divide 8. So that is 45 kilonewton meter. And the shear force is UDLW times L divide 2, which is 10 times 6 divide 2. So that is 10 times 6 divide 2, that's 30 kilonewton. That's the shear. And we will calculate the reaction for this example. Let's put that as point A, point B. So here is reaction RA, reaction RB, which is just simply supported. So RA is equals to RB, which is 10 times 6 divided by 2, most likely the shear value, 30 kilonewton. Okay, now let's try ETABS. I have already set the grids here. So let's have this beam. So this beam is a 6 meter span, 6 meter span length, and let's assign it as a simply supported. So this will be boundary condition will be pin, and let's apply loads. Assign frame loads like a UDL, that's 10. So for this example, the UDL, the self-weight is assigned to 0. It means the self-weight is not calculated for this example, self-weight of the beam. So we have a 6 meter span, we have a UDL of 10, and let's try to analyze it. Okay, let's check the bending moment of this UDL. 45. And the shear, let's make it a little bit smaller. With there, the other side. Shear, it's 30. 30, 30. And let's have a look with the reaction. The reaction would be, yeah, that's FZ here. It's also 30. Same answer, another method. Finally, let's test Structura-GPT. This is a AI-powered GPT. So let's try and analyze the simply supported that we have just completed earlier. So let's say we will type analyze simply supported beam with 6 meter span and 10 kilonewton meter UDL, uniformly distributed load. Calculate the bending moment, shear force, and reactions. Okay, let us see if it gives the correct bending moment, shear force, and reactions. Enter. To analyze a simply supported beam that goes here, it's calculating, it's calculating. Okay, so let's review. So using the Structura-GPT, we asked to calculate the reactions at the supports, shear force at key points, bending moment at key points. So we have a beam span of 6 meters, we have a UDL of 10, and the support type is simply supported. So the support reactions earlier, we calculated as 30, which is point A and point B. Same calculations we did. The reactions at both supports A and B, similar with the manual and the ETABS. Now for the shear force, same answer. It's plus minus 30, that's the direction. Bending moment at section X at the left end, which is, this is at the midspan. Maximum bending moment, of course, at the midspan at 3 meters, which is 45. Same thing. So the maximum bending moment at center is 45 kilonewton, and it gives a summary, like what's your reaction, maximum shear, maximum bending, and it says here also the bending moment diagram is parabolic or concave down, and the shear force diagram is linear plus 30 to minus 30 kilonewton. And there's also a code reference, load definition and basic analysis, British standard, because this Structura-GPT is using British standard, and structural analysis theory by Cole, structural engineer's pocketbook, which is, I have this. And also there's a question, would you like to proceed with drawing bending moment and shear diagrams, or explore the design of structural section to resist? Okay, let us see. Provide the bending moment and shear force diagrams. Let's see. Analyzing Wow, look at that. It gives a shear force diagram and a bending moment diagram. A shear force diagram starts at, that's going up from the neutral axis, 30, and it goes down, decreases linearly to minus 30 right support, which is correct. And bending moment diagram, it's a parabolic curve, which is, look at that, 45 kilonewton meters at midspan, and then 0 at both supports. These diagrams are crucial for structural design, especially for locating maximum stress and sizing reinforcement or section modulus. Would you like help designing or steel concrete for this beam? Okay, even asking about how we'll be able to design the section. We'll give that in the next video. We have here a comparison table showing the maximum moment and maximum shear results. It shows that for all three methods, manual, ETABS, and EI Structura-GPT, the results are the same. The main difference lies in the time taken, which is only an approximation and can vary depending on the complexity of the task. We have here the disclaimer. When using ETABS or any AI-powered related structural engineering calculation tools, iStructura-TV still recommends verifying and checking the results using the fundamentals of structural engineering analysis. In some cases, performing manual calculations is the best way to confirm accuracy. All right, share your thoughts. What do you think about using AI in structural engineering? If you have suggestions or feedback on any structural engineering calculations, please leave them in the comments. Stay safe, everyone.